Hi, and welcome to Ions Made Super Easy. The idea of this presentation is to show you how to use the periodic table to tell just about anything you want to know about ion formation, to sort of use the periodic table as a big gigantic cheat sheet. So, what we're going to cover, first, how an atom develops a charge to form an ion. So in other words, how does sodium become the sodium ion, for example. How to determine the charge of an ion. You'll notice here that the charge on calcium is +2, whereas on the sodium ion it's +1. Then of course we get some with negative charges, like the phosphide up there, which is -3. What happens to the size when a cation or an anion forms? Also, not incidentally, what a cation and an anion is. What causes ions to form? And so we'll start out with a little bit of basic vocabulary. First of which, the most important of which, is the word ion, which is an atom or group of atoms that has a positive or a negative charge. And on the periodic table, especially, what we're going to be talking about is how this comes from losing or gaining electrons. Cation is a positive ion. Cations have lost at least one electron. They don't gain protons. That would change it into another element. But they lose electrons, causing an imbalance in the number of electrons and protons. So the other thing of note is that atoms of metals are the ones that tend to lose electrons to form cations. So the other thing to notice is that, for example, this little illustration here, this purple sphere represents the outer electron cloud. And so when it loses an electron, it pulls inward and then develops a positive charge. It pulls inward because there are fewer electrons to the number of protons, and that allows the nucleus to pull tighter around the electron cloud. It develops a positive charge because you've got one more proton than you do electrons. A few other things. An anion is a negative ion. Anions have gained at least one electron, which means, of course, they've got more electrons than protons, which, of course, means they have the negative charge. Atoms of nonmetals tend to gain electrons to form ions. And as you would imagine, the electron cloud expands, so the ion is larger than the parent atom. So we're going to, again, kind of represent the outer electron cloud with the purple sphere here. But this time we're going to be adding an electron, and it's going to be, this way it's done a little bit more obvious. The size expands, and you develop a negative charge. But what also happens, I'm going to rewind this just a second. What also can happen is that atoms can gain more than one electron. They typically do this at the same time. So they'll gain this electron, then boom, they'll gain another one, and they'll gain a negative charge for each electron that they take on. I want to make sure and put up front that everything we talk about is going to be excluding the transition elements. That is, everything we're going to be talking about deals with group A elements, about how to add or subtract electrons or whatever. The transition elements have a completely different setup, and we'll talk some about them later. But for now, just please understand that everything we're talking about is within group A. The overview here of how to tell the charge when an atom forms an ion, we have to start out with one kind of concept, and that has to do with the noble gases. The noble gases have a stable configuration, and every other element on the table practically wants to have that stable noble gas configuration. If the periodic table were a high school, the noble gases would be the cool kids. They're the one that sets the trends. Everybody wants to be like the cool kids. It works for an analogy anyway. So the elements are going to do pretty much anything they can to lose or gain electrons to get to be like the noble gases, to get to have a stable noble gas configuration. Now, they're not becoming noble gases, they're just having the electron configuration of a noble gas. So, for example, fluorine, it only needs one electron to get to be like neon, to get to have a stable noble gas configuration. So when it gains that one electron, it will become an ion. But this is something important to remember for beginning people. Remember that when an atom gains electrons, it's gaining negative charge. All too often, students initially will want to say, well, we're gaining, that means it'll have a positive charge. No, it's gaining negative charge. So that means the charge on the fluoride is going to be -1. Just like over here with potassium. Potassium, its nearest noble gas is over here with argon. So it would have to lose 1 electron to get to be like argon. And I'm just going to draw this over here to keep from being convoluted back and forth. So when potassium has a noble gas configuration like argon, remember here it's losing electrons, it's losing negative charge, which means in this case you're going to have 1 extra proton, so that the charge on the potassium is +1. Right. So with another couple of examples here, for example, sulfur, I mentioned earlier, you can have this happen with more than 1 electron. Sulfur will gain an electron and then gain another electron to get to be like argon. And again, it's gaining electrons, so it's gaining negative charge, so it becomes sulfide, which has a -2 charge. Likewise, magnesium, it's a lot easier for magnesium to lose 2 electrons than it is to gain, 6 more. So it's going to lose 2 electrons to become like neon, all right? And since it's lost 2 electrons, it's going to have 2 extra protons. The charge on the magnesium is going to be +2. So those are 2 fairly good examples there. Also, somebody will always ask, and it's a good question, all right, over here they tend to gain electrons. It's easier to gain electrons on this side. It's easier to lose electrons on this side. What about group 4? Because you could conceivably gain 4 electrons or lose 4 electrons. The short answer to that is don't worry about it for now. The ones that we deal most often with are going to be carbon compounds, which have covalent bonds instead of ionic bonds anyway. But like I said, there's an entire unit that's devoted to that. So the short answer is don't worry about it for now. You wouldn't be getting any questions about that, about ionic compounds anyway. So, all right. So example questions you might get. The nice thing is you can do one little manipulation with an element on the periodic table, figuring out about the electrons lost or gained, and you can answer just an entire group of questions. Like, for example, what's the charge on lithium? What stable noble gas configuration does it have after forming an ion? How many electrons? So let's look at lithium. Lithium will lose 1 electron to have a stable noble gas configuration like helium. When it does that, it's lost that electron, it's got an extra proton, so that means it forms a lithium ion with a +1 charge. We just answered all 3 questions all at once. All right, so for another one, what's the charge on chloride? What stable noble gas configuration? How many electrons does chlorine lose? All right, so over here is chlorine. The answer on the last one is it does not lose any. You'll sometimes see a question like that, and it's meant to make sure that people are paying attention and know what's going on with electrons being lost or gained. But I want to emphasize on that last one, the answer to that is 0. It's actually going to gain, and that's not a trick question. That's just basically making sure people are paying attention. Anyway, chlorine is going to gain 1 electron. That 1 electron has got a negative charge, so it'll form chloride. All right, and it has the stable noble gas configuration of argon, obviously. As a final thing, I just want to use the elements nitrogen through neon as an example for something. So here's the electron configuration in the Alpha diagram for nitrogen, and then the same thing for oxygen, and then for fluorine, and then for neon. But the thing that I wanted to point out here is, say, for example, with fluorine, if you add an electron to fluorine to form fluoride, or if you add 2 electrons to oxygen to form oxide, or if you add 3 electrons to nitrogen to form nitride, every one of these has an identical electron configuration to neon. That sometimes goes past people at first, realizing that the electron configuration of each one of these ions is going to be exactly the same as the noble gas they're adding or losing electrons to try to get to be like. So if there's a test question saying, what is the electron configuration of oxide? Well, it's going to be exactly the same as neon, and the same is going to hold true for nitride or for fluoride, or for that matter, for sodium or for magnesium. So that's the last little bit that I wanted to close with, and I believe that is it.